Hello and welcome to this session. This is session 4 of Unit 5, Taxation and Government Expenditure in Ghana. In this session, we're looking at taxation and efficiency laws. In the previous session, we looked at the concept of tax incidence, that's who bears the burden of tax. So based on that concept, there is some inefficiencies or loss of or efficiency loss of taxation there. So in this session we are going to look at these tax inefficiencies and how to compute these tax inefficiencies as well. So at the end of this session, we are expecting that we will be able to explain the tax inefficiency or efficiency loss of taxation, calculate the magnitude of tax efficiency loss, total revenue, and the ratio of efficiency loss to total revenue, and also explain the concept of optimal commodity taxation rule. So with tax inefficiency, we are looking at how sellers and buyers, or the producers and consumers, change their behaviors just to avoid taxes. Right now, whenever there is an imposition of taxes, the consumers and the buyers may want to change their ways of doing things in order just for them to avoid paying these taxes, and then this will lead to the government not being able to fulfill the purpose of that particular tax. Right now, we increase this tax or introduce these taxes to generate revenue, but then the people who are going to give us these revenues have changed their behavior. So then there becomes a problem, right, in terms of getting that revenue that we need for the purpose that we need the revenue for, right? So that's basically the tax inefficiency or efficiency loss of tax, right? So if two systems of taxation cause the generation of the same amount of tax revenue, the one that causes the lesser magnitude of efficiency loss is referred to the one that causes greater magnitude of efficiency loss. So assuming the government introduces some two taxes, and then one particular tax that the government introduced causes greater efficiency loss and one causes lesser efficiency loss, basically the government will go with the one that causes less efficiency loss, right? So we are going to look at how to compute these efficiency losses, and then the revenue that the government loses from these efficiency losses, and then how the government can consider dealing with these efficiency losses, right? So we are saying mathematically efficiency loss is just as how we compute the area of a triangle, right? So how the area of a triangle, as we know, is length, breadth, half base times height, right? So that's how we compute our efficiency. So that's the half base times height. So we, based on the sketch or what the demand curve that we have, we will be able to take out a portion which looks like a triangle, and then we'll be taking the length, the base, and then the height of that particular triangle as deduced from the equilibrium curve. Okay, so this is just as the curve that, or the quadrant that we looked at in the previous session, where we were saying that if there is an imposition of taxes and then prices increase to some level, the consumer, the buyer may transfer all tax burden or some portion of the tax burden to the consumers, right? So we are going to use that same curve to explain our concept of efficiency losses. Right now, assuming the government has imposed a tax of 1 cedi, right? So there is a tax of 1 cedi here, that's from 0.28 to 0.3.8. So that tax of 2.8 has led to the increase of prices to 3.8. Now, if the good is elastic, we are saying the buyer, right, and the buyer is willing and the seller is also willing to sell at this point, that's where the price at 3.5, right? So in that case, we are saying that this is the point, or this is the price that the government is going to get, right? And if prices increase to 3.8, the demand so move to what, 0.90, right? So if that's the case, then there is this portion of the tax imposed that the government may not get, right? So that the people might change their behavior. So there is that portion that the government might not get. So in this graph, the portion of tax that the government might not get is this huge part. That's the from 0.28 to 0.35, right? So we are saying that portion is the inefficiency of tax or the efficiency loss of tax. So we are saying where T is a lump sum of tax and a change is a change in quantity, right? We are saying from the figure that we just looked at, that's figure 5.5a, let's assume that the T is 4 and then the change in quantity is 10. That's from the change from 100 units to 90 units, right? And then the tax imposed is 4. I said that the magnitude of efficiency loss here is 20. That's half base times height. The formula is saying half base times height, and then the base that we are looking at is from the 100 to 90. That's the 10, and then the tax here is what the tax that was imposed is what 4. So if that's the case, then we're going to have half times 4 times 10. That's going to give us an efficiency loss of what 20. So based on this efficiency loss of 20 and based on this fall in demand and then a tax, we can estimate the government tax revenue, right? So we can also estimate the total amount of tax revenue generated by the government. So from the same graph 5.5a, as a result of the 4 series tax imposed on goods and services, quantity supply and demand fell to 90 units. So meaning the revenue becomes the 90 units multiplied by the 4 series tax imposed. So that's how much revenue that the government is going to get from that particular tax that was what imposed. But then remember, there is some portion which has been lost. If the government has taken some factors into consideration, he would have gotten more than this amount that he had. That's the 360 Ghana cedis. Right, so the degree of elasticity is formally defined as the ratio of percentage increase in demand. So we looked at this in our previous session. So since there is inefficiency whenever tax is being imposed, or there is a loss whenever tax is being imposed, what should the government do, right? So then that one leads us to the concept of optimum commodity or taxation, right? So this rule states that the government can reduce efficiency loss from taxation by setting higher taxes on commodities that have inelastic demand and lower taxes on commodities that have elastic demand. Now, if government poses tax on commodities of elastic demand, remember there will be a loss of what demand. So we are saying the government should impose more tax on commodities that are what inelastic in nature, because for those ones the change in price relates to what a smaller change in quantity demanded. Therefore, the government can make more there than he will make if he imposes higher tax on commodities which have what elastic demand. So, but then there are some drawbacks to this particular rule, right? The first one being that it's not easy in practice to determine each good's elasticity, right? Now, we can't just sit here and then determine the elasticity for a good like gobe or for a good like Gary or for a good like vehicles, right? So it's very difficult in practice to determine these stuff, right? It will lead to wasteful lobbying of politicians by producers seeking lower rates for their own goods. So we know how this system works here. Mostly it is who knows the authority, right? So if people know the authority, then they can go and lobby their way out, meaning they are going to be getting lower rates on their commodities, and those who don't know anybody at all, like such commodities might have higher rates. So these are some drawbacks for this rule. So we've looked at how taxes affect commodities, and then how these taxes which are being introduced have some losses, and then we've looked at how you can compute the total revenue that the government may be able to generate from the introduction of some taxes, and then some we've looked at the concept of how government can reduce some of these losses as well. So we can take some few minutes to recap what we have discussed so far in this session.